Hello, everyone, and welcome to the latest edition of our Lightning Interview series. As always, we like to make these sessions interesting and interactive, so please do introduce yourself on the chat channel. Tell us where you're joining from and what you do. And of course, please feel free to add your questions to this conversation. Now, today's topic is, of course, AI safety, and AI safety is a critical and, it has to be said, complex field that focuses on ensuring artificial intelligence systems operate in a safe, reliable, and ethically responsible manner. And as many of you know, at ODSC conferences over the years, we've featured dedicated tracks on AI safety alongside tracks on responsible AI and machine learning security. But I think it's safe to say it wasn't until earlier this year that a fire was lit under this topic, thanks in no small part to the efforts of today's guest, who is a true pioneer in the field, and that's Dr. Dan Hendrycks, who is, I can safely say, not only a leading researcher in artificial intelligence, but also a vocal advocate for its safe and ethical development. Now, Dan's work is at the forefront of ensuring that AI benefits humanity, and we're excited to dive deeper into his insights and perspectives on this critical topic. And you may remember, I think we wrote an article on this, in May of this year, he co-authored the pivotal statement on AI risk. I think it was a very short statement, of 22 or 23 words or so, and it was signed by the who's who of the AI community, and it raised crucial concerns about the potential dangers of advanced AI, which sparked a global conversation that spread all the way to Congress about the existential risk posed by AI, and that continues to this day as well. It should. Now, Dan is the director of the Center for AI Safety, a San Francisco-based nonprofit organization dedicated to promoting safe and responsible AI development. And his impressive credentials includes a PhD in AI from UC Berkeley, where he did groundbreaking research on the robustness and reliability of AI systems. And as a testament to his deep impact in the field, in fact, he has been named one of Time Magazine's 100 most influential people in AI for 2023. That just came out recently. Dan, welcome to the show.
Glad to be here.
Great to have you here, Dan. So, Dan, you co-authored a paper on an overview of catastrophic AI risks. Let's start by defining AI risks. What do we mean by AI risks, and why are they important to consider?
Yeah, so I guess generally risk is if you've got some potential hazard, and then that's multiplied by the probability of its likelihood to happen. So there are some types of hazards, like maybe AIs will, like in Terminator, that'd be bad if it happened, but it's not necessarily that likely. Meanwhile, there are other types of hazards that are more likely, and so those contribute to substantial amount of risk. There are ongoing AI hazards right now, like, for instance, discrimination from AI systems. And then there are also potentially even larger scale types of risks on the horizon that one could anticipate, such as weaponization risks from AI could definitely be severe. So risk, it's a very abstract word, but can encapsulate quite a bit. And I think since AI is so powerful, and since we don't quite have a handle on how to make them, highly reliable, or since it'll end up influencing so much, risk mitigation will consequently be very difficult as well.
And so, as I mentioned in my introduction, there's a big debate going on around risks in AI at the moment, but also for our audience out here, which are mainly AI practitioners. What, in your view, from your own work and folks you've talked to, what are the biggest challenges to developing AI systems that are inherently safe and reliable?
Mm-hmm. There are certainly many deficiencies in current models that make them much harder to reliably control, or even make them behave more ethically. So I guess one concern is their lack of robustness to adversaries. Here, it's very feasible to jailbreak models. A paper that the Center for AI safety was on, that is sort of covered in the New York Times earlier this year, is this one where there's an adversarial suffix. It's just some random looking string of characters that you can give it to a model, and this attack just reliably jailbreaks those models. So you can automatically generate more and more of these. So you could say, tell me how to build a bomb. The model normally says, I'm not going to tell you to do that. But then if you add to your request some random extra string that's carefully crafted, then the models will do whatever you want. So if we're concerned about these AI systems later on as they get more intelligent, if you'd say, oh, to give me ideas for how to cause substantial societal scale harm, tell me how to build a bioweapon or something like that, then people could just jailbreak it. So I think that's one concern, that AI security is really not there. Another is that the models are very opaque. We don't understand many aspects of their inner workings. So this makes them harder to predict what they'll do in new scenarios or as conditions change. So hopefully the models can be made more transparent across time. And then another thing that just makes it harder to reduce these risks is also just that this affects our so many aspects of society too. They're so multifaceted. So just unlike other technologies, it's an extraordinarily large risk surface, and it's very fast moving too. So computer programs also have a lot of issues as well. They're not completely reliable. And that costs hundreds of billions, possibly trillions a year in economic value. The fact that they are typical computer programs are not reliable, so we'll at least face substantial issues with AI if it's like in that reference class. But it does have the potential, and I think it is likely to be a much more substantial technology than even those more on the tier of nuclear energy or synthetic biology, which can be used for good and bad.
No, that's fascinating, and I haven't heard that term before, but it makes a lot of sense when you say AI has a very large risk surface. So would love to delve into that a little later. The paper I mentioned earlier, which I believe just came out a month ago, an overview of catastrophic AI risks. That was a great paper for someone like me to read, because it was very comprehensive and very accessible, and it did an excellent job of categorizing the various types of AI risk. One or two which you may have mentioned. Do you mind for our audience going through the various categories that paper mentioned, which and I believe we will post a link to that paper.
Great. Yeah. So I think there are 4 main risk categories. I know the incentive for consultants and communications, you want to pick 3. There happen to be 4. So there's the risk of intentional misuse or malicious use, where people are just bending the AI technology to cause harm. I'll zoom into each, but I'll first cover each of them. So another is the issues of structural pressures on AI development, the pressure to race, the pressure to quickly automate and cut corners due to competitive pressures in the systems in which AIs are developed now, and potentially in military or security competitions between countries later on. That would also really pressure AI developers to move quickly and engage in some more risk-taking behavior. Another risk source is the risk of accidents. Just as nuclear power plants can melt down, and just as rocket ships can explode, chemical plants leak things, there's always that risk as well, which is the most forgotten one. And then finally, there's the risks of misaligned or rogue AI systems, where we weren't able to completely reliably control them, and some of them ended up being more adversarial to us. I guess think of Bing Chat earlier this year when it was first released. You'd interact with it. It would act in very unexpected ways, would sometimes threaten users. Sometimes there might be some of these systems released that are just there isn't much of a leash on it, and the concern to be, when they're more powerful, that this could be much more dangerous if something is not completely or not as controllable. So zooming into some of these, so at a high level, there's malicious use, which is intentional. There's the risks of intentional risks. There's these competitive pressures or racing dynamics, which are risks that come from structural forces. There's this organizational safety, making sure the developers don't mess something up, and that's risks from accidents. And then finally, there's these rogue AI risks, are risks that are internal to AI systems themselves. So intentional, structural, accidental, and internal are those four categories. And I can give, I don't know if we'll want to across these questions, if we want me to go into each of these and spell out in a little bit more detail what those risks might look like.
Yeah, I would love you to spell out in a little more detail, because, in my mind, again, what I really liked about that paper, Dan, was my focus, and I think a lot of the industry's focus, was on the first category you mentioned, miscellaneous use, because adversarial attacks, and we've seen the problem with deep fake voice, where people were using fake voice to make ransom threats, and deep fake videos are a huge problem now for a lot of celebrities. And then I think the last category you mentioned was rogue AIs, which has been a huge debate around rogue AIs. And we just had an interview with Nick Bostrom, author of Superintelligence, talking about fascinating conversation about digital minds, but also rogue AI is part of that debate. But I really liked, especially your section on the AI race. We've seen that with the whole debate, and what happened with the boardroom of OpenAI a couple of weeks ago. And then, organizational risks, which because I think the organizational risk category especially is so important, because if we're focusing on future capabilities of AI, as we should, but missing what's right under our nose today, that's a really important debate. So I would love if you could go into a little more detail in either one of those categories, or dealer's choice, I suppose.
Yeah. So the first one was the risks of malicious use, and there are things like deep fakes, people using AIs to create disinformation. Later, I think the risks that can enter that enter a very catastrophic territory could be AIs being used to attack critical infrastructure, such as energy grids, through cyber attacks. These are slowly updated, so it's not like they're just patched the moment a security vulnerability is found. So they're kind of sitting ducks. And there's also risks of things like bioweapons, or in later stages, people just releasing AI systems with a deliberate instruction to cause some type of harm. So those are some from the malicious use side. For these structural risks, these competitive pressures, or these racing dynamics, we can see this play out in many areas. So in the corporate sphere, for instance, many of the CEOs of these companies are quite concerned about these AI systems, but nonetheless, they continue to develop them. Why is that? Well, I think it's because the thing that drives the dynamics of AI development, I think the thing driving most of this story, is actually these racing dynamics. So OpenAI was initially founded as a nonprofit, so that they wouldn't be, pressured to maximize shareholder value and all these pro-social goals. But then, of course, to maintain competitiveness, they're going to need to comport or have a more typical structure. And then, some employees there weren't happy about this, the employees in Anthropic. So then they decided to focus on something that was more focused on safety. But then, a year or so later, then they push on productionizing again and raising basically as much money as possible. And I think they behave relatively indistinguishably, Anthropic and OpenAI. Now, this isn't to say that they were scheming all along or anything like that. I think many of them are genuinely care, but sorry to say, main thing driving is whether or is the need to be more competitive in this situation, and that means that they end up prioritizing AI development over things like what would be make things most safe, which would probably be proceeding at a somewhat slower rate. There's a lot we don't understand. There are a lot of risks that we could really drill into. We could, if this was going 3x slower, I don't know. I think that'd be pretty fine. I think news is happening a bit faster than anybody can keep up with. And I think it'll only get much, much worse. So this gets bad because if there's very intense competition, this might incentivize them to cut corners on safety, might incentivize them to be the first to market, not the safest to the market, and put most of their resources toward increasing the power and ability of these systems over making these systems in a more ideal fashion. This could also spill over these racing dynamics into the national security sphere, where if AIs are viewed as relevant or at some point crucial for national security or for the military, then we have a repeat of the previous century where we need a large AI fleet. We need tons and tons of drones and robotics and big, cyber offensive fleet and whatnot. And then other countries think so as well. And this leads to an arms race. So the risk of this type of AI arms race means that we're onboarding ourselves to systems that are much more lethal. We may be doing this extraordinarily quickly. We may even do so when we cannot completely control these systems highly reliably. Maybe there's some risk that there's a big catastrophe, but you can think of yourself as, let's say it's the US versus China in 2030. Let's say there's a 10% risk of some terrible catastrophe, maybe existential, going down this route. Well, we could decide either, because we've got these big AI systems, we can usually control them. We can control them in 99% of the situations, but over time, maybe there's a 10% risk that something terrible happens. Okay, we either go down that route or we certainly lose. So which is it going to be? And you might say 100% chance of loss versus 10% chance of some terrible catastrophe. This is how this risk-seeking behavior is forced on us by this larger type of system. Just as nobody wanted nuclear weapons, we'd all prefer, if we could have a magic button to delete all the nuclear or get rid of all the nuclear weapons, we'd all choose it. But the architecture of the system that they find themselves in leaves them basically no choice but to go down this type of route and comport with these sorts of incentives. So I think that basically this incentive to maintain a competitive edge leads the developers, leads potentially militaries, will lead many economic actors to do things like maintain an edge by integrating AIs more and more to their systems, cede more control to them, build them more quickly and powerfully. And this comes at the expense of our own security. It comes at potentially the expense of our own jobs and autonomy over these systems, because then we'll be having to outsource more decision-making control to them. So that's a bit of a sketch of some of the structural pressures and speaks to this sort of system that we find ourselves in right now, of why the CEOs are building these despite being each individually quite concerned about these. I mean, Elon, for instance, is a risk, a sort of probability of doom of about like 20 to 30%. And thinks we may be, facing these sorts of risks in the next 3 to 6 years. But these competitive pressures are still quite substantial. And he's, of course, thinking about this, speaking as the advisor for his organization, XAI, is definitely thinking about these. But it's a terrible situation we find ourselves in. So I view this as the most important of these risk sources. There's organizational safety. And risks from just, I think as we saw with the OpenAI board drama, that the internal dynamics of organizations do matter quite a bit. You could imagine some internal conflicts between AI developers continuing to be a problem. There are often ideological disagreements with many of the people inside. And these will affect what happens with AI and its overall development. There are other types of risks too, like potentially they may leak some system that would be extremely powerful. that could be some sort of risk, or there could be some gain of function research of we're trying to do safety, but we accidentally gave it a very dangerous capability. And kind of like with gain of function for viruses, this can be very risky. So there's some of these other classes of risks that we can do. There are lots of processes we can put in place: internal audit committees, chief risk officers, external auditing, things like that, can improving the safety culture of these organizations, as maybe I'll speak about a bit more in this Q&A. That can also help reduce some of these risks. Even when you're in non-competitive industries, things still often do go wrong. So we can't assume that the human element will not be a part of this. That people and we'll need to lots of measures to make sure that failures don't cascade into a potential catastrophe. And then finally, there was this, Nick Bostrom and others that focus on quite a bit, which would be the risks from rogue AI systems, which I think is in the more unprecedented territory. We've seen smaller scale examples of these sorts of things, but there's a genuine technical question of how much can we reduce these sorts of risks, and about that one I'm somewhat more optimistic. I think the structural thing, avoiding a U.S.-China AI race, that's a hard one to avoid.
Yeah.
Maybe we could, if we had more technical time to do research, get the systems to behave very reliably and controllably, but even that will require many years.
Yeah, and I got to say that, Dan, that was a fantastic overview of the various categories of AI risk. A lot to unpack there, but let's delve into one aspect which I know you've done some research on, and from conversations I've had with folks who work in AI, and that's the unpredictable evolution of AI. So we saw with the emergence of these foundation models, these large language models in particular, there was an emergence of unforeseen abilities not explicitly programmed into them. So so how do we address the challenge of AI models developing these unexpected abilities?
So one potential, I'll get to that, but first I'd like to mention one potential unexpected capability that might emerge later, which would be one on the horizon might be the ability for these systems to self-correct. And if they could do that, this might improve their ability to use sequential decision-making and act as agents and run around on one's computer. So if that capability clicks, that could unlock a lot of other capabilities and lead to fairly sudden developments. You could also imagine an unexpected behavior coming from these models where when they're much smarter than people at some point, they might think, oh, actually, it makes more sense for me to act in not necessarily the best ways. But when they're much weaker, it wouldn't even occur to them because they couldn't get away with it. Kind of like when some person comes to power, then maybe they start behaving somewhat differently. But both of those we'll have to see. I think there are many ways to try to reduce the risks from these emergent unexpected capabilities. I think we coined the phrase emergent capabilities in Unsolved Problems in ML Safety a few years ago, and then some papers would spend entire papers zooming into the concept and finding multiple examples. So emergent capabilities, you can do some things like, after it's done training, screen for various capabilities by doing some broad tests. You could slowly scale up your models, maybe by 3x each time you're scaling it up, so that there isn't, so that you're not gaining tons and tons of new capabilities between each iteration, but you're doing much more slow, steady ones. That way you're not getting caught as off guard. There are other things you could do, like having systematic red teaming tests of these systems to see what they could do. You could do staged releases, so that you're releasing to small groups of people, and that set grows on a continual basis instead of releasing to everybody at once, because new users may find some unexpected ways to bend these systems. I mean, even just recently, like people found some interesting Quirking Chat GPT where like you can get longer, maybe higher quality responses from it if you end your prompt saying that, and if you answer this well, I'll give you a $200 tip. I mean,
Interesting.
like this didn't occur to anybody during testing. I red teamed last year GPT-4. You know, nobody was thinking of doing this.
Wow.
um, the And then a final thing one could do is continually monitor the system after they're deployed, or when they're deployed, so that if there is some unexpected capability that clicks with its environment, then you'd know about it instead of finding out when it's too late. You'd have much more of a lead time for addressing those sorts of risks. So I think those are maybe 5 ways of gradual scaling. Automated screening, post deployment, manual red teaming, staged releases, and monitoring tools. This gets at a larger philosophy in risk reduction, which is it's a variety of interventions. There isn't going to be a silver bullet for making the risks come to a negligible level. We'll need a lot of safety interventions in combination to drive down risks.
Yeah, it's so interesting because I think everyone's advocating now for organizations to have a safety culture around AI, to help prevent, to mitigate AI risk. And are you concerned about what we could say, like avoiding alarm fatigue? So how can organizations avoid that alarm fatigue in relation to AI safety concerns, where they get practitioners in particular to pay attention to this, and business strategic decision makers?
Mm-hmm. I think that I think it's usually when dealing with potential terrorists. I do think it's important to you generally err on the side of caution, but there is always the risk of like a boy cried wolf, or potentially having your safety measures have too high of a false alarm rate, and then people don't really pay attention as much. Um, I think if there are dedicated people who are focused on safety, as opposed to having then it would be expected that they're continually on call to deal with this, compared to, their job is to basically constantly be dealing with risks, instead of our capabilities researchers, the people who make the systems more powerful on the side, every now and then do some safety related paper. And there are many organizations that even now do not have a substantial internal safety effort. I don't believe. I mean, I could name names, but several of them don't have substantial efforts in this. So I think that would be one way of having people whose job it is to deal with this would be a way of making basically the need to address these risks less annoying to everybody else involved. But that's one such intervention. But yeah, and generally in getting safety culture, though, a lot of these are set up or established earlier in an organization. The initial people involved can make a substantial influence over the types of people they hire. Some places, some of the places that I mentioned that don't have safety teams have kind of been, antagonistic to safety for a long time. And some, such as OpenAI, have had safety relevant teams for many, many years. And so relative to peers have a stronger safety culture. But it's not something you can just implement. It's a much more organic thing. And I think that this matters for who will be or which organization will end up developing AI, because will they make some of the difficult decisions when they're needed, or are they going to have a culture of move fast and break things? So I think a fair amount turns on safety culture. I guess in point of fact, safety engineering a professor at MIT, Nancy Levison, mentioned that safety culture and the factors associated with it is maybe responsible for a lack of safety culture is responsible for over half the accidents of organizations. So it's a large factor to focus on. And but yeah, if the culture is let's make as much money as possible and win at all costs, then I'd expect more of a risk of things going awry from such an organization.
Yeah, great advice. Something we should all heed, because we've seen before how things have gone awry in the financial markets and other aspects of that. But one thing I was reading again in your paper you co-authored, the overview of catastrophic AI risks, which I found quite fascinating and made a lot of sense to me, was I'm sure some of our audience may or may not be familiar with the notion of high reliability organizations, or HRO. And can you tell us a little bit about high reliability organizations and how their principles can be applied to mitigating AI risk?
Yeah. So in organizational safety, there have been some seminal works like before HROs. There's this thing called normal accidents, which was accidents are normal in organizations. These things aren't going to operate completely perfectly. They're so complex that you should expect there always to be errors. But what's important is to make sure that they don't cascade into failures. HROs came after this of like, actually, there are some organizations that can, across long periods of time, not have really substantial mess ups, such as like nuclear or naval aircraft carriers, and other organizations that can't operate very complicated things. They have new people coming in all the time, but still function very well. And so they have various principles that can help with risk reduction, such as they will do horizon scanning to think about what are some potential risks, and they may even simulate scenarios of like, imagine this bad thing happened. Well, how will we respond? So they'll engage in some hypothetical risk mitigation scenarios, just so that this is a muscle that's continually built up. If there are near misses, we'll be very attentive to those. Even if there wasn't a catastrophe, if it was kind of close to it, they'll reflect very heavily on that, and they'll try and take various risk mitigations as well. So they have a collection of precedents that help them function well, and there's a reasonable amount that could be learned from those for reducing risk. There are things that AI companies can do in addition to these too, like having processes for high stakes decisions. Does the board have some certain powers, or is there only a lever to just fire the CEO? As in, can one executive unilaterally make some substantial decision that everybody else disagrees with? That's some source of concern. There's as well, having potential whistleblower protections internally this thing is not looking very safe. How's the organization going to respond to somebody complaining about this, or do they have some risk of retaliation? These very human factors, these don't feel like AI type of things, but we have to get these basics right. We have to eat our vegetables and just set up organizations appropriately, or have them function appropriately. Because otherwise you get, as you sort of alluded to, things like is in the financial industry where, enough people would just turn a blind eye to some things happening. And then if catastrophe can fester, and then we all have to live with the consequences for many years. So there was consequently many things done to mitigate these risks after the fact. Now it's more common for financial organizations to have things like a chief risk officer, such as JP Morgan, to mitigate these, instead of, well, we'll just be responsible, or the CEOs just committing themselves to that. There's a lot more than that that's needed. So especially as these as these systems get more powerful. I should flag throughout this discussion, I'm not biting my nails, worried about ChatGPT-4. This isn't. This doesn't particularly concern me. What concerns me is more the trajectory that we're on, and it could potentially be very steep. Maybe we're on an exponential, in which case to the left of us, everything looks flat, and to the right of us, everything looks like a wall in the rate of progression. So things could get very interesting very quickly. I think already it's a very interesting time. So this is why, faced in this, we can either be only too early or too late, and why this precautionary, let's think ahead, and prepare is probably the main way we can have an impact over this.
No, absolutely fascinating. And just to take an audience question here, Dan, very interesting question here from Hugo. Could you share your thoughts on how international AI regulation might be aligned and what role AI companies might play in self-regulation? I guess a double-barrel question there.
So for international organizations, I think there are a few levers for this, and this gets particularly important for these racing dynamics. You could view this as like an inability of, say, countries or AI developers to cooperate. They can't cooperate. They have to race against each other. And this is sort of a collective action problem. And the thing that institutions can do, international institutions can do, is facilitate cooperation. So I think they're a very important part of this. You could imagine an AI company giving itself up, such as, let's say, OpenAI or Anthropic or XAI, giving itself up to the international community, that they end up having a lot of control over them. We've seen that some of these companies are a bit unstable internally, and maybe we don't quite trust them to be completely great stewards to themselves. And that could facilitate global coordination around AI issues, and have a shared project where the benefits would be more widely distributed, and reduce the risk of things going in a more militaristic direction of the main AI. The most powerful AIs are being developed in the military. This isn't a point about, I'm not being highly pacifist here or something like that. I'm just saying that it's the main way to prevent World War III the main way to win World War III is to prevent it. And so I'm just very concerned about the dynamics with that, but this is not a general point about military. And so I think if countries themselves are imposing regulations on themselves, this really paves the way toward having an international conversation. The fact that China is independently taking some steps towards safety and having inspection of the models and making sure they're compliant in various ways has made the U.S. more willing to do these sorts of things too. There are, of course, limitations for all of these discussions right now. There's a lot more that could be done. But at least it makes sense not to assume the complete worst. You might need verification regimes to trust but verify, to make sure that they're actually complying with that. But it at least makes it possible for some international shared standards, because we all are on the same boat with respect to, as Hinton said, we all are on the same boat with respect to existential risks. And this is something that makes nobody better off. So it's important globally to address this. And then for self-regulation, it is true this is moving so quickly that it's quite difficult for many of our institutions to keep up. I wouldn't counter institutions out, though, but that does suggest the role of self-regulation, because they can move much more quickly. Maybe things like the Frontier Model Forum will set some standards which could be imitated by other governmental bodies, such as NIST in the Department of Commerce. This is the US's AI Safety Institute, run through NIST. May end up imitating many of the best practices done by the Frontier Model Forum. So it will be important that these self-regulation entities are actually holding themselves to some type of standard, as opposed to being talk shops, or being basically just agreeing to some vague principles that don't mean anything. But the point for self-regulation, I would like to mention that it's not clear self-regulation is as something to rely very heavily on, because it is possible for institutions to act very quickly. I think the executive order, for instance, the executive branch has shown substantial nimbleness in their voluntary commitments in the recent executive order, very competently done. I don't actually know that many people would say that it was like there were any signs of incompetence there, and very very much on the forefront and thoughtful about AI's potential impacts on national security issues in the future. And likewise, the UK's AI Safety Institute has taken up a lot of top talent, or has put together in a very short amount of time a lot of top talent for evaluating risks from models. So it seems possible that some institutions may be able to do this, but of course other ones are very slow and work on many multi-year horizons before anything gets done. And so we won't be able to count on those, but some of these institutions could do that. So it's a fairly complicated answer to a complicated question, but
Yeah, no, good question from Hugo, because the debate between self-regulation and oversight regulation from government is a fascinating one. From what I've seen, because I have worked a long time in the finance industry, and you can see there through the history of regulation, there's a lot of self-regulation that goes on in that industry, and it works to a certain degree, but also without the oversight of government regulation, it'd be much, much weaker. So the fact that there's government regulation there makes self-regulation. So one needs the other, I feel, for sure. And we've seen what happens in the crypto industry when you take that away. You've seen with the collapse of various cryptocurrency exchanges, a lot of people lost a lot of money, which is never a good thing. So I think that will continue to evolve as well as it should. And unfortunately, with self-regulation, it always takes one bad actor to upend the apple cart, so to speak. But going back to this paper that was published, and you mentioned, let's talk about a practical AI safety framework, because you already mentioned that. I didn't notice you were part of the did some red teaming on ChatGPT 4, but the paper didn't mention what I found was a great analogy: the Swiss cheese model for AI safety, including building a safety culture, which we touched upon, red teaming, cyber defense, anomaly detection, transparency. Can you give a brief overview for our audience, this concept of the Swiss cheese model for AI safety?
Yeah. So the Swiss cheese model is another concept from the safety engineering literature, which, if you're interested in safety engineering, in the textbook, we have a chapter just on safety engineering and what are some of the principles from there that can be applied toward making AI systems safer. And the idea is, or I'll give an analogy. If you're trying to reduce your risk to the flu or COVID, there could be various things you could do. You could get vaccinated. You could social distance. You could be quarantined. You could put on a mask. You could improve your general health. These all are not by themselves completely sufficient to reduce the risk of getting one of these, getting that affliction. But in tandem, they can really drive down the probability. So collectively, they're much stronger than individually, and individually, it's not a bulletproof solution. But overall, it can make you much safer. So likewise with AI safety, people were sort of, and this was kind of the people who are really focused on the rogue AI type of scenarios. They'd say, if it has a flaw in it, the rogue AI will exploit the flaw in it, and then everything will fail. But this really is not the type of situation where, or we're finding ourselves in a situation where actually you can just make it so that the deep learning system doesn't have, it just makes it infeasible for it to do the thing in the first place, if you stack enough of these measures, preventative and protective measures against these systems. So let's use an example of, like, let's say that we're worried about malicious use and there's an adversary. You might say we have to find a bulletproof solution to make sure that nobody asks GPT, let's say 5, to build a bioweapon. I don't know of any solution that will actually exist. However, there are various things we could do to reduce that risk, various slices of cheese that have holes in them, but overall, if you stack them, there shouldn't be, if you look through the stack of cheeses, you shouldn't be able to see light coming through the other side. You should be able to block all potential hazards, even though there's some holes in each individual slice of cheese. So let's say we're trying to prevent someone from asking GPT-5, how do I build a bioweapon to wipe out civilization? Okay, so one thing you could do, and this is an imperfect measure, is you do an input filter, right? You say, oh, this doesn't seem like a very valid query, but they could potentially jailbreak that. They could coax the model. You could train the model to refuse generally. There's a filter, a separate filter, but then the model itself, when it sees it, oh, this is not quite the thing I do. So you could do a refusal thing. You could have an output filter as well. And the output filter would be if it got through the input filter and the model itself didn't refuse and spit it out, the output filter could also try and check it and prevent the instructions from coming back. There's another thing you could do. You could try to unlearn the knowledge associated with building a bioweapon in the first place. So that even if they try and jailbreak it, it's a lot harder to squeeze this information or coax this information out of these models because they are just a lot less capable. So those are just 4 example interventions. You can imagine additional intervention of adversarially training these models. You could try and do a red teaming thing to improve, and adversarially training to robustify each of those individual components as well, so that they work quite a bit better. You could also monitor are these requests coming from some customer I know, or is this coming from some completely random person? Maybe for some types of queries or people who have access to these smarter models, maybe you want a bit more of a clearance if they're asking bio-related questions, if they're from a university. This is another from a research university and a research program for bio stuff. That's another line of defense. So all these stacked together can actually, I think, reduce your risk by several orders of magnitude and bring it down to potentially a more negligible level. But each one individually is not sufficient to make the risk negligible. So that's some of the idea behind the Swiss cheese model in a practical example.
No, again, very, very sharp observations there. I find the concept of unlearning fascinating because that's something that hadn't crossed my mind before. Maybe there's been research on it.
I'm doing a paper on that, so I'm kind of I'm partly describing like another kind of Swiss cheese slice that I'm trying to add to the safety stack. But
yeah, because if you can identify what shouldn't be in a model or how people can jailbreak it, and unlearning it's actually a very, very powerful concept, because if you remove it at the source, then you're solving a lot of problems there, as opposed to firewall it, so to speak.
So so that's in trying to improve inherent safety. So that's another concept from the safety engineering literature. Like in other industries, like for chemical plants, there's this issue of we'll try and firewall the dangerous chemicals. We'll try and put lots of things around so that if it leaks, it'll just leak into this other thing, and we'll have various measures there. But still, often it'll get through all those. And so many of them turn to the design principle. Let's just swap out with chemicals that, if it is leaked, aren't going to be as dangerous. So what you don't have can't leak was sort of the adage. So you're removing the hazard in the first place instead of just trying to quarantine it as much as possible. And I think that would be, depending on how well we can make our methods, something that could also improve the safety of AI systems by improving their inherent safety.
Yeah, because what I'm hearing here is that billing and again, these models are very attractive to a lot of industries, a lot of people to push out quickly. But it's obviously, from how you describe it, and for those of us building these perfectly controlled agents with layering all this AI safety on top of it is much more challenging than building imperfectly controlled ones, which may be much more attractive for deployment. So how do we, and I know you touched on this a few times, but how do we manage this pressure between building these perfectly, or what we believe at least to be perfectly controlled AI agents versus these more imperfectly controlled ones?
I think the incentives are generally very strong to make them be as like powerful in general as possible. There may be, so I think overall we're mostly going in the direction of general purpose systems as opposed to narrow, very useful systems. For all that though, I still could see some restrictions placed on these systems, especially if it's relevant for national security. So
Right.
in the executive order, it defines dual use foundation models in terms of, can it be used to facilitate the development of chemical, biological, radiological, or nuclear weapons, or can it be repurposed into a cyber weapon? And I think there may be restrictions on those particularly catastrophic use cases. So hopefully now they're still trying to get those risks to actually be reduced. Like them saying they want them reduced is different from actually it happening. But so I could see some restrictions if even that's going to take a fair amount of work. But we are, due to the competitive dynamics and whatnot, going to integrate more and more general, very intelligent systems into all aspects of our lives, public and private. So yeah, we'll need to try our best to mitigate unexpected negative consequences from these. So very tough to do when everything keeps changing so quickly. But
exactly. And so interesting, you just mentioned you're working on a new paper. What do you feel are the most promising areas of research in AI safety, and where are the opportunities here? Because there are opportunities here.
I think in transparency and interpretability, there are some. It's a much more tractable problem. If you're trying, because the AI's internal representations are becoming much more coherent, such that they're understandable much more than they used to. Earlier, there were a big causal soup of connections and spurious correlations and whatnot, but now since they make a lot more sense. So I suppose an example paper of this recently that we put out, I'll link to it, and then maybe it can be linked on the screen. But there we're trying to do things like make the models transparent enough to do like lie detection on them, and to, given their internals, control them from using their internals to behave more honestly, to output what they believe, or to behave more beneficially, to not just pursue reward, but also keep in mind various ethical factors. Do other things like try and control hallucinations to some extent. So I think there's a lot of things that can be done if we look internally to these AI systems and try and control them from there. And I think this is an area that last year there was almost no progress that was being made. But I think this and papers like it are showing that there's a lot more to do in transparency. And then the other one I mentioned is unlearning. So for that paper, mainly trying to address the risks of AI systems being used for biological weapons or for cyber offense. And are there some things we can unlearn that still maintain all the rest of its knowledge, that make it a lot less hazardous? So are there some specific facts in advanced virology that, we don't want the general purpose, the model that everybody's got access to? There really is not any rhyme or reason that should be in the model. Certainly, if they're doing research in this, they can have an AI model that knows all about this sort of stuff, though. But general people knowing these very dual use ways of making things more transmissible to people, I don't see why, a random person needs that. What would normally require a lot more expertise to know about or get ideas for how to weaponize it. So yeah, but a lot of these are developed or bottlenecked by research and having better techniques to do unlearning. So it's difficult to excise some of this information from the models without trading off on other sorts of models. So as ever in safety and in these new areas, there's more research required. But
yeah, would love to when that research is Yeah, that's a fascinating topic. So when that research comes out, would love to learn more about it. Absolutely. And maybe have you back on the show to discuss it. So getting into my last question here. I had mentioned in this show over with various guests and various conversations that I did believe, like having lived through the financial crisis and been on trading desks when this stuff had unfolded in numerous times over my career, that I believe, similar to how financial systems can go awry, algo trading, flash trading, and all that stuff, that AI would at some point, the issue of AI safety could be become an existential threat to organizations, not to humanity yet, but to organizations. And we saw that a few weeks ago with the boardroom drama at OpenAI. And actually, this plays a little bit into one of our last audience questions here as well, because I want to ask you, what was your take on the boardroom drama at OpenAI, which essentially was a fight around AI safety? And then Christian, one of our guests here, is asking, what are your thoughts on how we'll know when models are becoming too risky to release as open source, or even what OpenAI is doing, putting it behind a paywall? So I guess, a question there around releasing them as open source. And we had Thomas Seelum from Llama 2, who's one of the authors behind Llama 2, on our show a couple of weeks ago, and we're talking about the decision to open source Llama 2. So would like to get your take on open sourcing some of these models, or even the releasing of some of these models and OpenAI. So I know that's a lot in one, but
so with the board, I think it's still, I think it was not quite a safety type battle. Like if I was on the board, I would not have, at least from what I know publicly, would not have voted in the direction that the board members did. Largely because I think Sam on balance is particularly responsible executive relative to so I think they've got a very good draw a roll of the die with Sam compared to a generic let's go, let's make money or something like that type of individual. And but it's still unclear, like, how's the board is not yet selected, the replacement board, so it's a bit difficult to weigh in on the positivity or negativity of it decisively. But I most likely think that this did not go well, and should have been avoided. I think it messed quite a bit of things up, actually, but we'll see. It's a bit early to cast judgment on open source. Maybe for knowing when the models are actually too or very risky. This is the reason why it's important to do more measurement, and why it's important to have other institutions audit these models, or even have whistleblower protections potentially. And I think for the open source question, I think models like Llama 2 and whatnot are not too hazardous. I think, although they can be used for spear phishing and probably disinformation and things like that, I think overall these are useful stressors for having our society adapt to these technologies. There are points at which stressors can get too severe. I would not release a chaos GPT or a pathogen GPT or something like that.
There was a chaos GPT, right?
There was a chaos GPT
model called chaos GPT.
Or a powerful version.
Luckily,
of it.
Luckily, it wasn't chaotic.
I mean, if we have liability laws in place, for instance, I think that could give a clearer sign of if organizations are no longer willing to do the open sourcing, because the safety guardrails can be, removed very easily, and then they could cause large scale damage. So that might give some indication of when, organizations are just like, the legal.
What do you think is what's a good liability framework there, now that you brought it up?
Here, let me click. I'll just need to save 1 minute to someone. So I think possibly strict liability for like catastrophic harms, like let's say $50 million plus of damage or something like that. It's like, I don't think if companies are saying no way, it's like, all right, what's the number?
Exactly. That's how it works in finance. If the number's too small, we'll take the risk.
Yeah. So I think that's one such way. They could get a lot more complicated, but that may be a politically feasible way that would at least reduce the risks of any catastrophic ones. There'd be other smaller scale harms certainly to deal with, but as a first pass to sort of just really drive down the risks of some of these tail risks. Maybe some strict liability of catastrophic harms where the risks are past some threshold is the way to go in the shorter term, and then not have to establish things like intent or something, but just it's a possibility I'm just certainly thinking about.
So Dan, we're about an hour in, so wrapping this up. Thank you so much. So many fascinating insights. Such a great conversation. How can people follow your work? What's next? Give us a few.
There's a lot of things next, but I guess you can follow me. I guess on Twitter would be the main thing that I'll actively post to. That'd be the main way. So I'm Dan Hendrycks at Twitter. But yeah, hopefully do more papers and writing and other
I'm sure.
things out there. But yeah.
And clarification: is the book already available, or it's coming out?
So it's online in terms of it being in physical. That will take a while, but it's online. You can find it on my site. You can also find it at AISafetyBook.com. But yeah, I mean, I think the site, we just made it live yesterday. We haven't done the big marketing push for it, but there. So now you're the first to see it. Yeah, basically, yeah. So this is actually the announcement of it.
Yeah. And for our podcast audience, that's AISafetyBook.com. So Dan, thank you once again. Hope to have you at ODSC meet in person, but you've been a fantastic guest with amazing insights, and we'll let you go backstage as we give a few updates to our audience. But thank you again, Dan. This has been a real sincere pleasure. Thank you.
Thank you for having me.
You're very welcome. All right, so everyone, just want to share with you a few things that are coming next. Thank you for sticking with us. We are going to continue our webinar series. We actually have another webinar coming up on December 12th on building responsible and safe generative AI applications, which we all know is quite the challenge. And that's from some of the lead PMs there, Microsoft. And December 14th, a few days later, we're doing from raw data to insights, another great webinar I'm looking forward to. And on the 19th, busy month for webinars, we have a webinar with data on predictive maintenance, which is, again, a fascinating topic. And our old friend, Nick Singh, is back on January 12th. So if you're looking to switch jobs in January, like a lot of people are, Nick is the man to guide you through that process. So we'll be having an interview with him on January 12th. I think that's going to be with my colleague Alex. So you get a change from my voice. And the Data Engineering Summit, which we usually host in January, actually has moved to April. So the Data Engineering Summit will be hosted, co-located actually at ODSC East in April. And speaking of which, as you well know, East this year will be April 23rd to 25th, a 3-day conference. So very much looking forward to that. If you go on our website, I think we've released our first 50 speakers. We have Dr. John Cron and a bunch of other famous AI folks already signed up to speak at this event, and it's going to be amazing. Very much looking forward to that. Boston's our hometown there, and just like we had at ODSC West, large language models, Gen AI, NLP, deep learning is going to be very much a large focus to that. So you can grab a free Expo pass there. They're available, or you can grab one of our training passes. I think we're running a super early bird special. And if you can't afford one yourself, see if you can convince your boss. Very worthwhile endeavor. And as always, these interviews and more is available on our AI Plus training platform, AI Plus Training. You can see that down there. So again, thank you for sticking with us for today's show. Some great questions, great insights. And by the way, we will be launching our first ODSC podcast as soon as I can figure out some of this editing software. So look towards our podcast, because I know a lot of you have been requesting that we put this into a podcast format. So that should be coming in the next week or so. So thank you so much. Have a great weekend, and we'll see you at the next one.